just very exciting, I think. Building machine learning models, it's like being on the cutting edge. Now run it again and see what happens. You get the same score. So this is interesting because in machine learning, what this is telling us is that even though like the weights are random to begin with, it's converging upon the same result. Some of the models have randomness built in, and you can end up with different scores. Linear regression is not one of those. What I want to do next, let's see if we can get a different score. So go ahead and add a new text header, and I'm going to call this one adjust model. Now, how do we adjust the model? Well, these are the lines of code that we have used. And what we can do if we're interested in adjusting the model, we don't need that header anymore, is we can look at the documentation. And so if you type in sklearn, linear regression in Google, the documentation will come up. You can see it's actually been updated somewhat recently because, I have a previous link, but that was when it was 1.5.2 and now it's on 1.6.1. So let's click on the newest documentation and see what we discover. So there are not that many parameters with linear regression. Okay, this shows fit intercept is true. Okay, that's sort of interesting. What is that? Well, the intercept, y equals mx plus b. If you make that false, okay, what it should do is convert to 0, 0. Okay, data is then expected to be centered, meaning it's not going to figure out the b, which would be like an x not in this case. So that is something that we could change. And I think that's about it. This copying, copying is not necessary here. The number of jobs has to do with like the processing that goes on under the hood. And let's check this positive equals false. Oh, this is interesting. When set to true, forces the coefficients to be positive. I mean, that's sort of an interesting idea. You would need to have sort of information about your data that you would definitely want that. Okay. So let's just, I guess really the only thing to change here would be fitting the intercept. Okay. And so it's kind of an interesting idea because in this case, we had the DF up. Well, hey, if there's nothing there, then the house has no value. 0 to 0 would make sense. So we could try that. So what I'm going to do is just copy this. Okay, we'll go ahead and put it down here. And what we can do is this fit intercept now, we can set it to be, I have to double check. Yeah, it's true by default. So we want to change that to false. And so when we do this now, we are going to end up with something a little different. Okay. And so what basically the difference, right? Instead of it going where it needs to go, it's going to force 0, 0 into it. Okay, that's my understanding. So let's run the code and see, do we do better than 0.641? I would assume no, because it's a little more restrictive, but let's see. 0.58, so comparable, maybe not quite as good, but okay, we've adjusted the model. And the reason why this is important, this adjusting the model, is because what you're going to find later is that some of the models, they have tons of different parameters that you can adjust. And that's actually one of their strengths to kind of making more powerful machine learning models. Other choices that you could make, you could delete columns, believe it or not, and even create new columns as a way to adjust your model. So let's just pull the code up again, the data frame again, the code for that, and we could consider, hey, are any of these columns problematic? I don't think so in this case. I don't think like deleting a particular column would help. The idea too of creating new columns, it might be, we could try it, something like, if we have, look, we've got total bedrooms and we've got population, so we can make a new column that's like bedrooms per population. Let me just show you how you would do that because it's kind of interesting. And it's sort of like interesting about mathematical modeling to think, okay, what the linear regression is doing, it's just finding weights. It's finding the multipliers for each of these columns. And so when you add a new column that it may potentially add something because it's meaningful to what you're trying to predict. Like the idea here, you would think that, is, bedrooms per population a little more insightful than these separately? Perhaps. Let's find out. So let's code it up. So to code up a new column, bedroom per population, I'll do it something like, it's in quotes, so we can do it like that maybe. And what we're simply going to do here is we're going to take the total number of total bedrooms, and we divide it by the population. And, if you're not used to sort of NumPy arrays, you might be like, what, you can do that? Yes, you can do that. It'll do it by column, and we'll verify. We'll just check out the df.head, and then we'll reset this up. This is kind of like a fun aside here. You can see there it is. Now what's interesting is let's just get the code going. Okay, so when we've added that column, I probably should have added it to the X. That'll make it a little easier. I think we're going to add it to the X because that way I don't have to reestablish X and Y. It can just be a part of the X. So let's verify once again. Okay. Don't worry about some caveats in the documentation right now. If it works, it works, and it worked. That's sometimes when things are going to change and you're going to have to do it differently later. Okay, so this has now worked. And I'm going to go ahead to keep the notebook going top to bottom, just copy in the linear regression steps and try it one last time. Now let's go ahead and put this back to true. It's the default, so you could delete it, but it's nice to have it up there. That way you recognize it's something that can be changed. And let's see if the score is any better. It's probably, my guess is it should be about the same, but I think there is some potential it could slightly improve. Basically, it's got to find an extra weight, and so there's some compensation potentially going on that could go either way. 0.650, maybe that's a tad worse. What did we have before? No, a tad better. It was 0.641. Okay, so keep that in mind as a cool strategy to potentially improve your data scores. You can, in fact, go back to your original data to make some adjustments.